share a link to the HackMD?
Yeah, I put it
in Zulip.
It's in Zulip, but I'll throw it in the Zoom chat too. Well, Scott and Josh, you all scheduled this meeting. I haven't prepared an agenda, but I figure we were going to go over the RFC. I did try to read through it. I don't know if other people had the time. Maybe we can start with some brief overview of it and go from there.
This is very much Scott's show. I am enthusiastically supportive and I'm happy to help wherever I can, but Scott?
Yeah, okay. I guess we should start in the motivation to talk about all the differences between what the goals I'm trying to accomplish here are. If you look at the RFC, the first bullet I note, the first bullet there is actually an experience report from Nico way back. When was that, 2018 or something? Yeah.
Yeah, it's a while ago.
The piece in there that I think drove most of the difference here is this idea of the residual type, that no matter what design we want, there's always going to be some type that has to come out of the question mark operator for the successful case. And it's very clear that that one needs to be some user useful type. But for the residual stuff, that's whatever the error case, if you imagine something like the comp ordering type, if that were to have question mark, it would be the less or the greater. That needs to go into something. The trick with the previous RFC is that it essentially requires that whatever that is be something that makes sense to have as the error type in a result, as it will always allow conversion into that. So Nico made the good point that once that type exists and is made to be reasonable to be used in a result, you're sort of stuck with, this is just, well, I could just use a result if I've done all the work to make that behave reasonably anyway. And then the other trouble with that is that if you have things where that being a result doesn't make a whole lot of sense, like the example of the ordering type, if that were to be try, it wouldn't make a whole lot of sense to have less or greater be an error type in a result, no matter what that was going to be. So one of the things that this RFC will do is that residual type is no longer designed to be shown to users. If you take a look in the guide level explanation down below, I put in something yesterday about a error code type that just shows a result code type, which has a holder for it, which is the residual type that is completely opaque because it's not expected that a user ever actually interacts with that type. I don't know if that was clear. I'll stop there for a second.
Made sense to me.
I'm not sure I follow what shown to users means here. Sorry. Is this a holder?
Yeah. So
okay,
the residual is the holder. The basically it's not expected here that a user actually has to interact with the holder type themselves. Basically, the idea is that you'd always use one of the other traits to get back to the original type and operate on that original type instead. Sorry, I know that type names and trait names are kind of bad here, but
so the ordering example isn't actually from the RFC. I've inferred that the OK or whatever the continue case, the OK case, I don't recall it, but is equivalency, right? But I'm just curious, like if there's a link to the sort of demo of why this is awesome for ordering.
Well, this wasn't so much of why that's awesome, so much as an example of not everything should be structured as results with a bunch of things in the error case.
I guess I'm inferring that the idea is that you would implement ORed and partial ORed by question marking the comparisons of each like in the field, and so it would sort of break early with less if you know one were less. Is that the idea?
Let's ignore the ordering one because it's not actually a very good example, because Libs has
Okay.
already said understandably that we probably don't actually want that one to be a question mark type.
Do we have another example that we know we do want to be a question mark type, or that we kind of are seriously considering?
So I've put in the HackMD a link to the result code example that I added late yesterday, so people probably haven't seen it. This one I think makes a lot more sense. It's basically like a C error no kind of a type.
The idea here was if it's not 0, you break, right?
Yeah. So you could use question mark on C error code kinds of things, and then you could also do this with we have an unstable exit code type that comes out of processes. So something like that could also work.
But now I'm not understanding why this wouldn't be result with an error, with a result of, you know, a unit and an error that's I32. So I'm still not getting it.
I had an example. I mean, in my original experience report, I talked about examples. I think this is what, I'm not sure how this maps exactly, but what I remember is that it was kind of 3 cases where there was 3 or 4 variants and you wanted to propagate them back. And what I wound up having to do was defining a sort of version of the type that doesn't carry the OK case. There was one that was OK and then various other variants that I wanted to propagate. And I wound up having to make like a version, a residual version that doesn't have the OK so that I could shoehorn it into result. And that was very annoying because it was like, I think I wound up, then I had 2 types that were kind of almost exactly the same. And at that point I wound up just using result instead, which was okay, but that wasn't the code I originally wanted to write. I wanted to have
Can I ask, Nico, as someone who's done a similar thing, and also, I actually, if I refer to like absol status and absol status OR, is that clear to everybody? Or do we need to explain that more?
Not for me, sorry.
Okay, yeah, no worries. So in C++, the like common convention that I'm familiar with is to have a type that defines a status code, and then that can be 0, or it can be indicating success, or it can be some other number indicating an error. And then pairing that with a status OR that is basically like result with the status as the associated error type, where the error type is assumed to be non-zero. So I've used this pattern a handful of times, or sort of been consuming this pattern a handful of times from Rust. And often what I've done is I've not made a distinction between the 2 types, the type that can contain a 0 and the type that is expected to not contain a 0 or OK, in order that I can use the same type conveniently in a result and just as the return value from a function. Does that all make sense so far?
Yes, I think so. It'd be nice if we typed it up, but okay.
And so I'm curious, Nico, in your example, if you were able to have just this sort of single status type that you could use question mark on, do you not also want the ability to say that status or some OK value? Because I've always needed both of those things in tandem.
Let me give the example from the thing. I had this type, and I wound up I wanted to use question mark on it, and I basically couldn't because, or I could, but I wound up defining instead kind of, or in order to do it, I would have had to define this residual type. And then I had to define like, and then I was using result T of strand fail. And at that point it felt like, well, maybe I should just use this. But, you know, as my, let's call this R, as my actual type, and that's what I did. Then I didn't have to do any impls at all. It was okay, but it just felt like it wasn't, the code wasn't quite as nice because now I had 2 levels in all my matches. This was the way I was happier with the code. Like that's the way I wanted to write it at first, because I didn't have a need for that variant separated from the errors, I guess is the point. I think you're saying, don't you often want to separate out the errors from the other variants anyway? And I guess the answer was no, I didn't. But yeah, if you did, then it's not such a problem.
Like in my mind, the way that like I would have expected this to work. So actually maybe I don't understand yet in your example why no solution, like why strand fail R it's worse because you have to have 2 levels of matches is the concern.
Essentially, yeah, that's right.
And you didn't ever have a use case where you wanted to pass around just a strand fail R or match on that?
I don't think I did. Yeah, not particularly. But even if I did, I would say that I would rather we address that by at some point allowing variants to have like types for variants and maybe subgroupings and things like that, which I know is a long-term thing. But I guess my point was also like, if you have that enum, then there stops being so much point to implementing the try trait at all. Like maybe we just don't need a trait. It's a little late for that now, so okay. But we could just hard code it to result, you know.
So I might have a concrete example where there's a very specific reason to not separate it out and call it a result. There's obviously been a lot of discussion about putting Rust into the Linux kernel, and inside the kernel there is a error handling mechanism that's extremely common of noting that there are no valid pointers in the first 4K page of memory, and therefore the low 4K values are not valid pointers. And so there is an error pointer encoding where you can have something that is either a valid pointer or an errno code, for which errno codes have that range. And this specifically has value because it is packed into a single pointer. It is not, it is potentially expressible using niches or similar if you were very careful, but you'd have to somehow say all pointers inside the kernel have a niche. And an easier way to handle it locally is to have this special pointer or errno type, and then define try for it, allow it to be propagated via question mark. You can obviously transform that at any time into a result of something and an errno, but that's not how you normally want to store it. You want to question mark it up through other functions that return pointer error, or eventually through functions that just return an errno value.
So I guess maybe I'm not following quite, Josh, but my impression from what you've said is that that is a perfect case for using result. Like that you would at some point you would sort of unpack into a result and then propagate the actual error or give someone a pointer, but the sort of, you would actually want a separate type for the errno, even though sometimes they are found sort of in this packed form. Maybe I'm not following.
So there is value that you can have a separate handling of the errno, but under normal circumstances, the type you want to use to hold a value and an errno is not result. Normally, you would want to use the error pointer value instead.
Sure. I guess what I'm trying to get at is that it feels like in that case, the sort of the question Nico brought up of like, it feels like that is a case for where strand fail R is not actually a bad solution in some sense, because you still want it.
Insofar as it's just an I-32, but
Sure. I don't know. Maybe I'm not quite following, but
It feels like this is not, at the end of the day, the most important thing about the RFC. Like there's more, there's a lot more in the RFC than just this point, right?
I'm personally willing to believe that packing, and also even the original example that Scott gave in the RFC, where it's just a number, again, like I'm willing to believe there are use cases where you want to leave it in the current representation and inspect it to determine what behavior to have. Whether that's, first 4K of memory, or if it's, it's equal to 0, either case, it's something where, okay, we're not going to use explicit enum. We want to still have interesting dynamic behavior with question mark.
Right.
yeah, that makes sense. Yeah, yeah.
I mean, I'm just gonna put in a little, like, rather than, this was kind of the heart of the RFC in some sense, right? These 3 traits. Where,
Yeah.
and I guess what we're talking about now is a relatively small part of it. It has to do with like some elements of holder or something. I guess not that small, but basically whether you hard code result. When we're still using this control flow, holder is in some way analogous to this result type, but you can choose whether you want to.
Yeah, let's take a look at the next bullet in the motivation section, because I think that gets into a lot more about what the difference is between the holder and the error type from the previous, from the current nightly try trait.
It sounds good.
So the next one here is the general try block question of, do you have to type annotate your try blocks all the time, always? The major problem we have with the nightly version of this is that once you've done the try into result method, you have lost any like family information that you might have originally had about the type that you came from. So you've split up your option into a T and a none error, and that is indistinguishable from having started with a option from a result that just happened to have a none error. Similarly, because the desugar of the question mark operator always called from, it was fundamentally impossible for its result to work without having some sort of contextual type information from inference. This is not a huge deal in function level question mark, because you have a result return type of the function which tends to provide that context, although that's not always the case, because if you're in a closure, you can still run into this trouble, as it is unlikely to be able to infer the type of the closure. So one of the properties that this uses of the difference between the holder type and the associated error type is that the holder type is in a sense colored to be, to keep its resultness or its optionness or various things like that. And then the break holder trait can be used to get a try type of the same family, but with a different continue type. So you can see this in the RFC in either the try find implementation example, or I put a zip demo as well that also does produce an output type of the same family as the input types.
One thing I wasn't totally clear on, the question mark desugaring, you mentioned that it changes and it switches to use bubble. Is that only within try blocks? Or it's-
That's always to use both.
Okay, that's what I thought. But wasn't there some backwards compatibility concern or not?
So
Tree is not stable, so
Or was it specifically that you needed those funky impulse?
so basically there's two possible question mark desugarings. This is mentioned in the end and future possibilities for the try block. We can't substantially change what happens for current question marks, but we would have the option to say, actually, we'll use this other desugaring of question mark in try blocks that are not type annotated, say.
Okay.
And then that question mark inside an unannotated try block would then, rather than using the contextual type by just calling try from holder and ending up with whatever type the context wanted it to produce, we could specifically pick the break holder output type to avoid needing annotations on things.
So am I correct, Scott, that in the current design of the try desugaring, or like the question mark desugaring, the output type on the break holder trait is not actually used anywhere, in the sense that it doesn't, like, you could put anything you wanted there and it wouldn't technically change anything in the current behavior of sort of the design. It's just useful to later be able to sort of hint at what the desugaring would be to.
Yes, with the stable surface area that currently exists, if we were to accept this RFC, the behavior of break holder would not actually be observable anywhere. Because the only question mark desugaring that you would be able to trigger is the one that relies on the contextual type, and the stable methods of the APIs also don't depend on doing the break holder things. The places where the break holder would be used in the future would be things like the unstable iterator try find method, which basically wants to be able to do this, as well as potentially in the future with try blocks.
Can you explain how that desugaring would work with try blocks? Because it seems to me that you wouldn't, like, you'd have to have it not trigger somehow if you use question mark on types with a different break holder. In the same try block.
I wasn't imagining it being that smart. I was picturing, say, we could have just try that doesn't mention a type, always produces the break holder type, and it is possible that that would not compile because whatever you were question marking inside that block had incompatible handler types, holder types. And then we could have an alternative syntactic form, say try as anyhow result, which would go back to using the contextual version of the question mark operator that could do the error conversion.
If you allow, like, just imagining the sort of user experience of that, I have like a couple of concerns, because it seems like you wouldn't start getting errors about the break holder type or the result type of the try block not being annotated, right? You would get errors that you had mismatched. I don't even know what the like one way you wind up with an inference error sort of always, right? And people just learn to always write the return type of try, which I think they're still going to have to do for results anyway, right? So this would only ever work for non-result errors. Is that right?
No, this would work for result errors when you do not need the from behavior of error conversion. So the couple of examples in the Rust mirror that use it to do a bunch of IO result things wouldn't need to annotate their types like they do today, for example, because everything there is producing an IO result of some sort, so it doesn't need the error conversion. And this would be fine as they all have the same holder type.
I see. So by default, you're imagining that try with no type annotated performs no error type conversion, and that if someone wrote an error type conversion, they'd get an error about like mismatched error types when using question mark. But if they annotated the results of the try block using some extra special syntax, we would desugar differently in a way that would start performing error type conversion within the try block.
That's right. And I think that's somewhat reasonable, because if we're going to do error type conversion, we need to know what we're actually converting the error into. There isn't, I mean, we can talk about some other trait of like, hey, here's the best common error type between these two unrelated error types. But that sounds scary.
Yeah, I don't like that solution either. I just also think that this, I don't know. It sounds surprising, and it seems like a lot of additional complexity to what right now I think people have like a fairly simple mental model of question mark as being like match on result basically, and then return in the error case. And this kind of, I don't know, I think substantially complicates that.
I'm still feeling a little bit like confused about bubble and breakholder and try, I have to admit, even after reading the RFC and what they're like, what is the kind of intuition I can grok for them?
Personally, the intuition that I found was that they allow you to manipulate types at the type level to say, give me the type of your overall type minus the successful items, and give me a type that is your overall type with this specific successful item stuffed back into it.
So if it helps, Nico, I kind of conceptualize this as that like bubble is what I had been thinking of as try. That's like the question. Bubble is like the question mark bit of things. And then try itself is the like can be the sort of result of a try block, or the return value of a function that has question mark within it.
And try is where the from conversion, if it's going to take place, takes place.
Correct.
Yes.
Okay. I mean, I guess I had that roughly. Breakholder. What is the role of breakholder?
Yeah. So if it helps, one of the thing that you can is the one thing that might help is that, like Mark was implying earlier, you can completely ignore breakholder for anything that you can do on stable right now.
Mm-hmm.
It is only for the higher kinded type level metaprogramming kind of cases that breakholder becomes necessary. Go ahead, Mark.
I think what I would say, my intuition, and correct me if I'm wrong about breakholder, is that essentially what it's saying is that there is sort of this coupling between the type, and it's trying to track that as well as tracking some value. And it's doing it by sort of connecting them in this other type. And the RFC sort of does that with these like result and option with bang types instead of like defining new ones, but that's a sort of, depending on whether you want to write a new type, you can do that, or you can do the option bang or result bang error.
Yeah, and it's the never type variation is interesting because that does give you a kind of easy way to make these residual types that we were talking about in the very beginning.
Right.
It didn't exist, I think, when I wrote that experience report, but
that is the intuitions for breakholder, is that it is effectively a type with a hole in it.
Right, and so it lets you put together, it's basically a type function that combines the residual type with a success type and produces a new value. I mean, I knew the type of those things combined.
I have a sort of, I don't know, maybe it's meta, maybe it's not comment about this, is that like, I found these traits hard to understand. And I don't know, like, I don't want to play too much of the, like, I have a lot of experience with Rust card, but like, I don't know, I feel like all of us collectively here have a lot of experience using Rust and understanding like complex trait relationships. And this was difficult for me to understand. And I'm concerned about introducing something that's that sort of like conceptually complicated to a pretty like early on in the Rust user experience set of features.
I don't know if this helps at all, but I had a different kind of trouble reading this, which is that I found eventually that all of the traits made perfect sense to me. However, I found that that was easiest by skipping ahead, reading the reference section, and then going back and reading the motivation and guide level explanation sections. I found that there was a lot of front-loaded information that assumed things that weren't yet written. There was kind of an ordering problem in the explanation. I didn't have any understanding, but there was definitely an ordering issue of why this type?
Yeah, I definitely was less confused by the reference level explanation than I was by the guide level explanation.
I think,
But that also could be a familiarity issue of that I'm like aware of how the current question mark desugaring works. And so I'm sort of looking for that. And so it's confusing seeing these other like types that I don't understand.
yeah, I guess I was also sort of concerned by that aspect of like potential confusion. I think for me, the most interesting bit is that it feels like the traits, like they're presented as a whole. And I think in practice, what we're sort of saying is that there's not actually that much relationship, right? Like bubble is for sort of one use case, and then you add try in if you want sort of a different thing, which is like the result type behavior. And then break holder is kind of just a helper trait. And I think sort of to me, I struggled with understanding them as a whole because they felt like they should be connected, but I think in practice they are not, um, in some like meta way.
Do you think the typical user experience of like interacting with these traits would be that they only interact with one of them?
That is like basically what I'm trying to get at is like my impression is that sort of if I'm, for example, writing a sort of try from each or whatever, or try for each function, then maybe I only interact with like bubble because that's the only behavior I need. But then if I'm like writing a result adapter, then maybe I interact only with try. But maybe Scott can say more if like I'm actually correct about that.
So you will need try to do trifold. However, you can mention only try because bubble is a super trait of try. Let me give another sketch of this that may or may not help. We'll see. The previous one had one type called try because it was willing to use associated types for both the from continue and from error type. In some ways, you can think of bubble and try as the same thing here. Bubble is in a sense like try base or try common or something like that, because the reason for that this ends up with two traits instead of just one is that bubble is non-generic and try is generic. So to have the, no matter what implementation you're going with, the type that comes out of the question mark operator is always the same. That requires a non-generic type, which ended up being called bubble here. And then allowing the type to decide for itself what kind of conversion it allows, including error conversion, takes a generic parameter. So in some sense, these are the same trait, but they can't be technically the same trait because one of them needs to be generic and the other one needs to be not generic.
I don't think the fact that there are two separate traits for bubble and try is what's confusing to me, because I think a lot of the earlier designs I'd seen about this also had the two trait property.
Can you articulate what you do find confusing?
I'm going to guess that it's the holder concept. It seems like there's an extra step of indirection there that isn't totally clear. Like bubble is clear as the sort of like it's question markable, and try is sort of clear as it's the result of a try block or function that uses question mark. But like break holder is this kind of weird thing, and the holder type is kind of weird.
Is that part potentially because it's an encoding of generic associated types, in higher order type construction, and that's and that's the way I at least am interpreting it, and that's purpose here. And if we had first class or whatever you call them, a high order
generic associated types.
Yeah, if we had those, we had the way to pass around the vector type constructor as a thing at the type system. We might opt to do that here, which I think is in the RC as it's something like, would we wait for that hypothetically if we saw it coming anytime soon?
I'm not sure I understand how you could actually use GATs here, because I think you want to be able to specify what input values you accept for the type T that's an input to break holder. Because
you'd have to bound the inputs. That's true.
Yeah, naively, like the GAT version of this that I'm imagining would have like type output inside bubble, and it would be generic on T, but you'd need a way to fix it so that some types can only break holder for one specific type of T, which isn't really how GATs work, right?
Well, GATs can have where clauses, but it's not
Right,
how our kind of types work usually.
You wouldn't have where clauses in the impl that weren't in the trait definition, right?
Right. Yeah.
That would be odd. I don't know.
Yeah, I didn't know how to bound this to support non-generic continue types in a GAT world. Part of that is I don't really know what type GATs would look like, but the RFC that talks about GATs also doesn't include type GATs. So,
right. I just meant in terms of the use case that you pointed out is the only case where you bring up break holder. It's clear to me that that's something where it seems analogous to GATs, type GATs.
Yeah, but
very much so.
For a really simple case, right? Like you could imagine that you have a result type that has like a fixed OK basically, and like a fixed error type, right? And in that case, you would want to only impl break holder for your specific type that you could continue with, right?
Is it possible that some of the problem here is naming though?
Definitely.
I think so, yes.
I'm thinking like, if I can let me just, at the very bottom, I just wanted to sketch something like, I'm starting to understand the rules of these things, but this is like this is clear enough. This is the on continue, here is what we produce. That's what this is, right? But this is like the holder is kind of the break, essentially. It's like in the event that we break, this is the value that gets passed, not directly to the user, because that's where the indirection comes from, but this is the value that will be tried or something.
Yeah, it's the residual, it's the family, there's a bunch of kind of ways you can conceptualize that.
It's self minus continue.
Yes.
Which is not the worst name ever, and the break, okay, I see why it's called like break holder, but the break holder is basically, it's just something that breakable types implement. Okay. I don't know if I know what the right names are, but I definitely feel like there would be better names that communicate. Rather than trying to make up the names, I want to try to communicate what the roles of these traits are.
So I guess maybe, Nico, can I interrupt real quick? So I guess maybe one thing to call out that at least for me is sort of confusing is that the trait bound on the break, as far as I can tell, like the fact that there's this like trait break or trait holder or break holder or whatever, like that it's not used in any of the defined, like none of the things use the output type. And so sort of I see it, but then it's unclear. It's acting as, I think, just constricting the set of types that can be there, which is not how usually I see, like I usually see a type, item with a trait bound, and then the functions I expect to use something about it. But here I think it's just acting as a restrictor on what types can go there. And for me, that's like unintuitive and confusing, even if it's like a normal thing to want to do, I guess.
Yeah, the restriction where the functionality comes back in is that the output type on the break holder type is constrained to be try. So you end up actually using that bound by producing the type and then calling from holder on it again.
Yeah, I guess the fact that the output
But
type is not mentioned in any of the trait impulse or like any of the traits, it feels like it's there. And I think it's there, again, is to constrain what types, sort of the relationship between the various types implementing things. But it feels like maybe we can move that constraint into, for example, bubble, and that would make things clearer to me.
Side note, I'm a little confused about what the change being made to break here is, since it's changed type tries parameters to no longer match try. Can I make the observation that if we're going to explore speculatively and attempt to redesign this, that we not do that in this meeting where we have valuable in-person time?
I don't think we were trying to redesign the traits. I think the question was just trying to figure out the role of the different ones, and there was some renaming happening in it.
I think it was a mistake to try to rename him. That was I regret that, but I
do value Mark's observation here, though.
Yeah.
This thing about output is really interesting because I'm now trying to figure out. I see output reference in like the try find example in the RC, but I'm really surprised it doesn't show up in the API directly.
yeah, I think it would actually be possible to remove the break holder bound from bubble. And then you'd only end up hearing about bubble holder in a sense in cases that do need to do the
I see.
the HKT style things.
So effectively, things that actually care about break holder would then need to write a much more complicated generic bound saying, I'm looking for a bubble where bubble holder is a break holder.
Yes.
That
If you take a look at the
makes-
try-find versus the try-fold signatures, the try-find signature is substantially more complicated, even with this bound, than the try-fold one.
Okay, I see.
I guess I'm just still, I don't know. This is also sort of a useful exploration, but I don't know how. Maybe it's worth polling the room to see like how people feel about the motivations for breakholder. I'm personally just sort of unconvinced that that's a thing that we need, but maybe other people feel differently.
So before we do that, can we make sure that we understand what the motivation is? And so my reading on that is that the reason for breakholder to exist is so that you can have sort of different type families. And you can say, for example, that option should not ever become a result without an explicit, for example, conversion, even if both of them happen to maybe want to convert to some other thing. Like the ability to split things apart is the thing that breakholder gives us. But maybe I'm wrong.
It is not actually.
My understanding. My understanding. Oh, sorry. Go for it, Scott.
So I think what you're referencing there, Mark, is the desire to say, hey, no, you cannot use question mark on a result in a method that returns option or other similar scenarios like that. You can't question mark on a control flow in something that returns result. And that is actually done just with try and bubble. It does not require the breakholder trait itself. The generic parameter on try along with result carrying that option, along with the holder type carrying the optionness or resultness is what does that part. The breakholder trait itself doesn't come into whether or not things can be mixed.
Okay.
What is the motivation?
For breakholder?
Well, so
It
there's
is entirely the higher kind of type scenario.
yeah, which and that includes the try case, right? The try block without type annotation, right?
Yes.
Is part of that.
Can you spell that out a little more? The higher kind of type scenario, like how
Yeah,
does
so I think Zip demo is actually a pretty good case study in why you need this.
I was gonna bring in that example. That's a good one. So this is the one you're talking
I
about.
have
right?
it pasted in the thing earlier. Yeah.
Okay. Sorry. Well, sorry. I pasted it again.
All good.
So, I mean, basically it's being able to go from, you have two things that have a common holder. I want to be able to recover the output or something.
You
Yeah,
want to
so
be
this
able to
one's doing it
construct
with
a new
two set.
output that's different. Go on,
Yeah,
Scott.
what Josh just said. The zip demo uses two because zip was sort of the simplest version of this that I could come up with. The try find example just has one, but it needs to take the user's closure that they passed in is producing a result of bool, and the try find wishes to return a result of option of item, or if the closure returns an option of bool, it wants to return a option of item, that kind of thing. So anything that needs to change the type to some other continue type is where breakholder comes in.
And in particular, in spaces where you don't want to have to annotate that manually, because I think if I understand correctly, you could use just the try bound to accomplish that if you required the user to specify the output type, in both the case of try blocks and things like try find or try.
Yeah, that's correct.
Okay.
If try find had a generic type both for the return type of the predicate and for the return type of the method, then breakholder would not be required, but additional type annotations would be required to call try find.
Yeah, that sounds right to me.
Whereas if you want to be able to just pass a closure and have the compiler infer based on the closure, oh, I see, you want this output from the overall function, then this will allow you to do that.
Which might fail disastrously in the case that you're using two different error types, right? And that's sort of the part that I'm concerned about.
Well, the
Sorry,
case
that is true for
a single closure, you'd have a single error type.
In the case of try find, yes. Sorry, zip demo is different, right? But yeah, and
So
try blocks are different.
So we've got today try find is unstable. I just want to get our sense also of what are the stability constraints here. We have today a try find and we have also a try fold, right? But try fold is stable to some extent or something.
Trifold is stable to call. It is not stable to implement because implementing it requires naming the unstable trait.
Got it. It's okay. So backwards compatibility is that as big a thing.
And trifold does not require this continue type change, so it's comparatively much simpler.
Why does try find require this continue type change? Because we're going to return back something with bool or something like that.
The user's the closure that's passed into try find returns a foo of bool, but try find wishes not to return a foo of bool, but to return a foo of option of the iterator's item.
Got it. So it wants to, I'll copy in the signature. It wants
What-
to search through the
Searching for an
iterator.
item. If you return a true, then you found the item. If you return a false, you haven't found the item. But you also want to be able to return an error, in which case try find should say, while I was looking for your item,
Mhm,
here's this error that I got instead.
got it. Forgive me.
I'm curious how people feel the motivation is for things that have a fully generic sort of like single constructible like OK type that don't use results is. That is like I'm just sort of not convinced that like strand fail of T above is interestingly different from like result of T or strand fail R in a way that we want to like bend over backwards to support using with these methods like try find.
It sounds like you're suggesting you're not clear on why we want to have types other than result for handling errors, or did I misunderstand your concern?
No, that's not it. So specifically, the place where break holder is useful is when you have a success case that is constructible from a generic success value, right? Potentially with some bound, right?
Mm-hmm.
Yes.
And the places where that's useful is where you're working, where your type that implements bubble and try has a generic parameter that or is able to do some sort of conversion into its success case from a variety of OK types. So for example, can hold bool and can hold whatever the result of what is found is. Does that make sense? Sorry, I know this is confusing. The way I'm saying this is not clear.
Let me give another shot at that. I'm going to paste something in here at the bottom.
We're at the 2-minute
what you're
mark, by the way.
Yeah.
I have a hard out.
Yeah, so do I. So if I try and rephrase what you're saying, Taylor, saying, hey, I'm break holder of parent is not providing anyone any value because it will never be able to be used generically.
Right, it can't be used inside of try find, right? That won't actually work.
Right. So because there's almost no cases where you could use that break holder, it's not valuable to require people to say that you are a break holder of unit.
Right. The interesting case for break holder, if I've followed all the examples correctly, is where there is a sort of uncovered success case that it can hold any kind of arbitrary success. And then there's some other set of values that can be held, right?
All right. I'm gonna.
Yeah. Go ahead, Nico.
I was just gonna say I've got to drop too, and it seemed like a number of us had hard stops. So let's end the meeting. Clearly, we're not in any consensus state, but this was useful to understand better, and we'll keep talking about it. Thanks, Scott, for pursuing this.
Yeah, thanks, Scott.
All right. Thanks, Scott.
Thanks,
Bye.
all.
Bye.
Thank you.